Langchain AI21ai21base. Description: This is a Langchain wrapper for the AI21 Labs AI21base model. It allows you to easily leverage AI21's powerful text generation capabilities within Langchain. Applications. Inputs. Prompt: the user's input text, serving as a prompt for the AI21 model to generate a response. Outputs. Text: the AI21 model's response to the provided prompt, generated using the AI21 base model. Steps. The user's prompt is sent to the AI21 API. The AI21 API processes the prompt using the AI21 base model. The API returns the generated text as output. Metrics. Perplexity. This metric measures how well the generated text aligns with the probability distribution of the AI21 base model. Lower perplexity indicates a more coherent and fluent response. Fluency measures how smoothly and naturally the generated text flows. Visualization plots. A visualization of the perplexity score over time, with lower perplexity scores indicating better model performance. Fine-tune parameters. Temperature controls the creativity of the generated text. Higher temperatures result in more unpredictable and potentially less coherent output. Lower temperatures lead to more predictable and potentially more repetitive outputs. Uncertainty methods. Bayesian methods. These methods could be used to assess the model's uncertainty about its predictions based on the input prompt. Challenges and fixes. Challenge 1: prompt engineering can be complex, and crafting effective prompts for the AI21 base model requires careful consideration. Sample use case that resulted in Challenge 1: a prompt that is too vague or lacks context may lead to ambiguous or irrelevant responses. Fixes to Challenge 1: experiment with different prompt styles, use specific keywords, and provide clear context to guide the model's output. Challenge 2: handling long prompts or lengthy text generation requests can lead to performance limitations or unexpected behavior. Sample use case that resulted in Challenge 2: attempting to generate excessively long text outputs or processing very lengthy prompts might exceed the model's capacity. Fixes to Challenge 2: break down long prompts into smaller, more manageable chunks, and use techniques like summarization or text splitting to reduce the computational burden. Langchain AI21ai21base AI21base. Description: The AI21 base model is a powerful language model developed by AI21 Labs. It's a large language model (LLM) designed for various natural language processing tasks. Langchain integrates with the AI21 base model through the AI21 base tool, enabling you to leverage its capabilities within your applications. Inputs. Text: the input text to be processed by the AI21 base model. This could be anything from a single sentence to a lengthy document. Parameters. Various parameters can be used to control the behavior of the AI21 base model. These include: temperature controls the randomness of the generated text. Higher values lead to more creative and unpredictable outputs. Top limits the number of possible outputs to consider at each prediction step. Top: a method to control randomness by selecting tokens based on their probability distribution. Outputs. Text: the AI21 base model generates text in response to the input. This output can be used for a variety of tasks, such as text summarization, question answering, text generation e.g., writing stories, articles, or code, translation, paraphrasing. Steps. Input processing: the input text is pre-processed and tokenized into a format suitable for the AI21 base model. Model execution. The AI21 base model processes the input and generates the desired text output based on the provided parameters. Metrics. Perplexity, a measure of how well the model predicts the next word in a sequence. Lower perplexity generally indicates a better model fit. Blue score, a metric commonly used to evaluate the quality of machine translation. Visualization plots. Attention maps. Visualization of the model's attention weights, revealing which parts of the input text are most influential in generating the output. Fine-tune parameters. Learning rate, the rate at which the model's parameters are adjusted during training. Epochs, the number of passes through the training data during training. Batch size, the number of training examples processed in each iteration. Uncertainty methods. Temperature scaling. Adjusting the temperature parameter can be used to control the models confidence in its predictions. Challenges and fixes. Challenge 1. Bias in the generated text. Sample use case. The AI21 base model generates text that perpetuates harmful stereotypes. Fixes to challenge 1. Train the model on diverse datasets that reflect a wider range of perspectives. Use techniques such as debiasing and fairness-aware training. Challenge 2. Inability to handle complex logical reasoning. Sample use case. The AI21 base model struggles with answering questions that require multiple steps of logical inference. Fixes to challenge 2. Use specialized reasoning models in conjunction with AI21 base. Incorporate knowledge graphs or external databases into the model's training data. Challenge 3. Limited context understanding. Sample use case. The AI21 base model generates irrelevant or incoherent responses when given long and complex input. Fixes to challenge 3. Utilize techniques like contextual embedding to help the model better understand relationships between words and phrases in the input. Explore architectures that allow for longer sequence lengths. Break down long inputs into smaller chunks. Langchain AI21 chat. Description. This chain utilizes the AI21 Studio API to interact with large language models (LLMs) for text generation, translation, summarization, and other language-based tasks. It leverages Langchain's framework for orchestrating the interaction with the AI21 API. Inputs. Prompt. The user-provided text input that serves as the instruction for the LLM. This could be a question, a request for a story, a text to summarize, or any other language-based task. Model. The name of the AI21 Studio model to be used. AI21 offers different models with varying capabilities, such as Jurassic 1 Jumbo, Jurassic 1 Large, and Jurassic 1 Medium, each optimized for different tasks. Outputs. Response. The generated text output from the LLM based on the provided prompt. This could be an answer to a question, a generated story, a summarized text, or any other text produced by the LLM. Metadata. Additional information from the AI21 API call, such as the model used, the request ID, and other relevant details. Steps. Construct the API request. The chain prepares the request to the AI21 Studio API, including the user prompt, the chosen model, and any necessary parameters like temperature or top. Send the request. The chain sends the constructed API request to the AI21 Studio API endpoint. Process the response. The chain receives and parses the response from the AI21 Studio API, extracting the generated text and any associated metadata. Metrics. API latency. The time it takes for the AI21 Studio API to respond to the request. Response length. The number of tokens or words in the generated text output. Visualization plots. Response length over time, a plot showcasing the number of tokens or words generated by the LLM across multiple requests, allowing for an analysis of how the response length varies with different prompts or models. API latency distribution, a plot showing the distribution of API latency across multiple requests, providing insights into the performance and potential bottlenecks in the AI21 Studio API. Fine-tune parameters. Temperature controls the randomness and creativity of the generated text. Higher temperatures lead to more unpredictable outputs. Top, a parameter used for nucleus sampling, which controls the probability distribution of the chosen tokens during text generation. Uncertainty methods. Confidence scoring. The AI21 Studio API may provide confidence scores for the generated tokens, offering insights into the model's certainty about the generated output. Challenges and fixes. Challenge 1: incorrect or irrelevant response generation. Sample use case that resulted in Challenge 1: a prompt requesting a story about a historical event might result in a generated text that is factually inaccurate or irrelevant to the specified topic. Fixes to Challenge 1. Improve prompt engineering, clearly define the desired output and provide context to guide the LLM towards accurate and relevant responses. Utilize model-specific guidance. Choose a model optimized for the specific task. For example, a model trained on factual text might be better suited for a question-answering task compared to a model trained on creative text generation. Challenge 2: API errors and rate limiting. Sample use case that resulted in Challenge 2: sending too many requests in a short time frame can lead to rate limiting by the AI21 Studio API, resulting in errors or delays in responses. Fixes to Challenge 2. Implement rate limiting. Implement a mechanism to limit the number of API requests sent per unit of time, adhering to the API's rate limits. Handle errors gracefully. Implement error handling mechanisms to catch and manage potential errors during API calls, allowing for graceful recovery and preventing program crashes. Utilize retries. Implement retries for failed requests, potentially with exponential backoff, to minimize the impact of transient errors and ensure that requests eventually succeed. Langchain AI21 Chat Adapter. Description: the chat adapter for the AI21 chat model in Langchain. This adapter allows you to easily interact with the AI21 chat model through the Langchain framework. It leverages the AI21 API for communication. Inputs. Query the user's input question or prompt. This is the text that is sent to the AI21 chat model for processing. Conversation history: a list of previous messages, tuples of role content in the conversation. This enables the model to maintain context and provide coherent responses in a multi-turn conversation. Outputs. Response: the AI21 chat model's generated response to the user's query, incorporating the conversational history. Steps. The adapter takes the user's query and any previous conversation history as input. It formulates a request to the AI21 API, sending the query and the conversation history. The AI21 chat model processes the request and generates a response. The adapter receives the response from the AI21 API and returns it as the output. Metrics. Accuracy: the correctness of the model's responses based on a benchmark dataset or human evaluation. Coherence: how well the model's responses maintain consistency and flow within the conversation. Fluency: the naturalness and readability of the model's generated text. Visualization plots. Conversation flow diagram: this could visualize the sequence of user queries and AI21 responses in a multi-turn conversation. Response length distribution. This could show the length word count or character count of a model's responses across different queries. Fine-tune parameters. Temperature controls the creativity and randomness of the model's responses. Higher temperatures lead to more diverse and unexpected responses. Top limits the number of possible next tokens considered during generation, influencing the diversity of the output. Top a method for controlling the diversity of the output by sampling tokens based on their probability distribution. Uncertainty methods. Confidence score. The model can provide a confidence score indicating its certainty about a generated response. Diversity sampling. The adapter can use methods like beam search to generate multiple responses and assess their diversity. Challenges and fixes. Challenge 1. Maintaining context across multiple turns in a conversation. Sample use case. A user asks about a specific topic, then follows up with a related question. If the model doesn't remember the previous context, the response might be irrelevant. Fixes. The adapter should store and utilize the conversation history effectively to maintain context and provide coherent responses. Challenge 2. Handling ambiguous or unclear queries. Sample use case. A user asks a question with multiple interpretations. The model might generate a response based on a different interpretation than intended. Fixes. The adapter could use techniques like query clarification or providing multiple interpretations to the user to resolve ambiguity. Challenge 3. Handling sensitive or inappropriate queries. Sample use case. A user asks a question that is offensive or contains sensitive information. Fixes. The AI21 chat model may have built-in safety mechanisms to prevent generating inappropriate responses. The adapter could also implement additional filtering or response modification to handle such queries. Langchain AI21 chat adapter. J2 chat adapter. Description. The J2 chat adapter is a Langchain adapter designed to interact with the AI21's J2 chat model. It allows you to utilize the J2 chat model for tasks like question answering, text summarization, and conversation generation within your Langchain applications. Inputs. Prompt the user's input or prompt that you want to send to J2 chat for processing. Model. The specific AI21 J2 chat model you want to use, e.g. J2 Jumbo. Temperature controls the creativity and randomness of the response. Higher values closer to 1 result in more creative and unpredictable outputs. Outputs. Response. The text-based response generated by the J2 chat model based on the provided prompt. Steps. The adapter takes the user's prompt as input. It constructs a request to the AI21 API, specifying the selected model and other parameters like temperature. It sends the request to the AI21 API. The adapter receives the response from the AI21 API, which contains the generated text. The adapter returns the generated text to the user. Metrics. Model perplexity measures the model's confidence in the generated text. Lower perplexity indicates a more fluent and predictable output. Response length indicates the number of tokens or words in the generated response. Visualization plots. Word cloud of the generated response. Timeline of the response generation process if available. Fine-tune parameters. Temperature controls the randomness and creativity of the model's response. Uncertainty methods. Model confidence scores. Some models provide confidence scores for the generated text, indicating areas of higher or lower certainty. Challenges and fixes. Challenge 1. The API call to AI21 might fail due to network issues or server unavailability. Sample use case that resulted in challenge 1. A user tries to query J2 chat during a network outage. Fixes to challenge 1. Implement retry mechanisms with backoff to handle temporary network disruptions. Challenge 2. The model may generate responses that are irrelevant or nonsensical due to ambiguous or poorly formulated prompts. Sample use case that resulted in challenge 2. A user provides a vague prompt like "tell me something interesting" and the model generates a response about a random topic. Fixes to challenge 2. Use prompt engineering techniques to make prompts more specific and informative. Provide context and examples to guide the model's response. Challenge 3. The generated response might contain factual errors or inconsistencies due to the model's reliance on training data. Sample use case that resulted in challenge 3. The user asks for information about a historical event, and the model generates a response that contains incorrect dates or details. Fixes to challenge 3. Consider using a combination of techniques. 1. Fact-checking tools to verify the generated text. 2. Incorporating external knowledge sources into the prompt or response generation process. 3. Training the model on more accurate and up-to-date data. Langchain AI21 Chat Adapter Jamba Chat Completions Adapter. Description: The Jamba Chat Completions Adapter is a Langchain adapter for interacting with the AI21 Jamba Chat model, designed to handle text completion tasks. This adapter allows users to leverage Jamba Chat's powerful capabilities within their Langchain applications. Inputs: prompt a string representing the user's input or the context for the completion task. Optional temperature: a float value controlling the randomness of the generated output. Higher values lead to more creative responses. Outputs: text: the generated text completion from the Jamba Chat model, based on the provided prompt and temperature settings. Optional metadata: a dictionary containing additional information about the completion, such as the number of tokens used, the completion time, or other relevant details. Steps: the adapter receives the user's prompt and any optional parameters, e.g. temperature. The adapter prepares the prompt for Jamba Chat's input format. It calls the Jamba Chat API with the prepared prompt and parameters. The adapter processes the API response, extracting the generated text and any available metadata. It returns the generated text and metadata if requested to the Langchain application. Metrics: completion time: the time taken by the Jamba Chat model to generate the text completion. Token usage: the number of tokens used by the model for the completion. Visualization plots: completion length distribution: a histogram showing the distribution of completion lengths for various prompts or temperature settings. Completion time distribution: a histogram depicting the distribution of completion times across different prompts or temperature values. Fine-tune parameters: temperature controls the randomness of the generated text. Higher values lead to more creative and diverse outputs. Max tokens limits the maximum number of tokens the model can generate for a single completion. Uncertainty methods: confidence score: some Jamba Chat API responses might provide a confidence score for the generated text, indicating the model's certainty about the output. Challenges and fixes: challenge 1: input prompt length limitations. The Jamba Chat model might have a specific token limit for input prompts, exceeding which can lead to errors. Sample use case that resulted in challenge 1: a very long and detailed prompt containing multiple paragraphs exceeding the token limit. Fixes to challenge 1: break down the prompt into smaller chunks and process them iteratively. Use a summarization or text compression technique to reduce the input prompt length. Challenge 2: Unpredictable output variation with temperature. Different temperature values can lead to significantly diverse outputs, making it challenging to control the generated text style and content. Sample use case that resulted in challenge 2: a prompt with a temperature setting of 1.0 generated very creative and abstract text, whereas a setting of 0.2 produced more straightforward and factual responses. Fixes to challenge 2. Fine-tune the temperature parameter through experimentation to achieve the desired balance between creativity and coherence. Use additional prompt engineering techniques to guide the model's output in the desired direction. Langchain AI21 Chat Factory Create Chat Adapter. Description: the Create Chat Adapter function within Langchain's Chat Factory module allows you to build a conversational AI using the AI21 Labs API. This function seamlessly integrates AI21's powerful text generation capabilities into your Langchain applications, enabling you to create chatbots that engage in natural, human-like conversations. Inputs: model name: the specific AI21 model you want to use for generating responses within your chat application. This can be one of AI21's available models like J1 Jumbo or J2 Jumbo. Chat history: a list of dictionaries representing the history of the conversation. Each dictionary contains role, user or assistant, and content the message text. Temperature controls the randomness of the generated text. Higher values lead to more creative and unpredictable responses, while lower values produce more deterministic and predictable outputs. Top determines the number of candidate words to consider during the text generation process. A higher value increases the pool of potential words, potentially leading to more creative or diverse responses. Top: similar to top, but instead of a fixed number of words, it specifies a probability threshold for the words to be considered. Words with probabilities exceeding this threshold are included in the generation process. Max tokens sets the maximum number of tokens the AI21 model can generate in a single response. This parameter helps to control the length of the generated text. Stop sequences: a list of strings that, when encountered in the generated text, will cause the model to stop generating further content. This allows you to define specific endpoints for the conversation. Outputs: Chat Adapter: an instance of the Chat Adapter class. This adapter acts as an intermediary between your application and the AI21 model, enabling you to send messages to the model and receive responses. Steps: Initialization: the Create Chat Adapter function initializes the connection to the AI21 API using the provided model name and other parameters. Conversation management: the function handles the management of the conversation history, passing the chat history to the AI21 model for context and ensuring that each message is correctly identified as either from the user or the assistant. Response generation: the Create Chat Adapter function calls the AI21 model's generation API to produce a response based on the provided context and parameters. It handles the conversion of the model's output into a suitable format for your application. Metrics: Response quality: the quality of the AI21 model's responses can be measured based on metrics like fluency, coherence, relevance, and faithfulness to the conversation context. You can assess these metrics manually or use automatic evaluation tools. Generation speed: the time it takes for the AI21 model to generate a response is a key metric for evaluating the efficiency of your chatbot. It can be measured as the time elapsed from the point of receiving a user's message to the delivery of the AI21 model's response. Visualization plots: Conversation flow. A visualization of the conversation flow can be helpful for understanding the back and forth interaction between the user and the chatbot. This can be a simple timeline or a more complex diagram representing the conversation structure. Response length distribution. A histogram showing the distribution of the lengths of the responses generated by the AI21 model can provide insights into the model's behavior and its tendency to generate short or long responses. Fine-tune parameters. Temperature. Adjusting the temperature parameter can fine-tune the model's creativity and randomness. Higher temperatures may lead to more surprising or unique responses, while lower temperatures might result in more consistent or predictable outputs. Top K and top. These parameters allow you to control the model's exploration of different vocabulary options. Increasing top or top expands the potential word pool, potentially leading to more creative or unexpected responses. Conversely, reducing these values may result in more deterministic or predictable outputs. Uncertainty methods. Confidence scores. AI21's API may provide confidence scores for the generated words or phrases. These scores can indicate the model's certainty in its predictions and can be used to assess the reliability of the chatbot's responses. Multiple predictions. You can request multiple predictions from the AI21 model for a single input. Analyzing the variations in these predictions can provide insights into the model's uncertainty or the potential range of possible responses. Challenges and fixes. Challenge 1. Incorrect or irrelevant responses. The AI21 model may sometimes generate responses that are not relevant to the conversation context or are factually incorrect. Sample use case. A user asks what is the capital of France, and the model responds with the capital of France is Berlin. Fixes. Ensure the AI21 model has been trained on a sufficiently large and diverse dataset that covers the relevant topics for your chatbot. Consider using techniques like response filtering or ranking to prioritize responses that are more likely to be accurate and relevant based on the context. Challenge 2. Limited context understanding. The AI21 model might struggle to remember past conversation turns or correctly interpret the context of the user's message, leading to responses that are out of place or miss the intended meaning. Sample use case. The user is discussing a movie, and the model responds to a subsequent question with an answer related to a completely different topic. Fixes. Increase the length of the chat history that is passed to the model to provide more context. Experiment with techniques like context distillation or summarization to condense the relevant information from the chat history into a more concise and digestible form for the model. Challenge 3. Repetitive or predictable responses. The AI21 model might fall into a pattern of generating similar or repetitive responses, making the conversation feel stale or lacking in dynamism. Sample use case. The user asks a series of questions, and the model responds with similar phrases or sentence structures, creating a sense of monotony. Fixes. Experiment with different temperature values to encourage more variation in the model's outputs. Incorporate techniques like persona or role-playing to encourage the model to adopt different voices or styles in its responses. Consider using techniques like response diversification or filtering to ensure that responses are more unique and engaging. Langchain AI21 chat models. Description: the Langchain AI21 chat models module provides integration with the AI21 Labs' powerful language models, allowing you to leverage their capabilities within Langchain. AI21 Labs offers a suite of models specializing in different tasks, such as text generation, summarization, and translation. This module enables you to interact with these models using the familiar Langchain interface, making it easy to incorporate them into your applications. Inputs. Prompt the user's input, which can be a question, instruction, or a piece of text. This prompt is sent to the chosen AI21 model. Model the specific AI21 Labs language model to use for processing the prompt. Different models have different strengths and areas of expertise, so choosing the appropriate model is important. For example, you might use Jurassic 1 Jumbo for creative text generation or J1 Jumbo for translation. Outputs. Response. The output generated by the selected AI21 Labs model based on the provided prompt. The response format will vary depending on the model and the task. It could be a generated text, a summarized version of the input, or a translated version of the text. Steps. Initialization. The Langchain AI21 chat models module requires you to provide your AI21 Labs API key for authentication and access to the models. Prompt creation. Construct the prompt that clearly instructs the AI21 model on what you want it to do. This could involve asking a question, providing context, or giving specific instructions. Model selection. Choose the AI21 model that best aligns with the task at hand. Consider the model's capabilities and specialization. Execution. Send the prompt to the chosen AI21 model using the Langchain AI21 chat models modules. Functions. Response processing. The AI21 model will process the prompt and generate a response. You can then use the response as needed in your application. Metrics. Accuracy for tasks like translation or summarization. Measure how accurately the AI21 model captures the meaning and intent of the input. This can involve comparing the output to a reference or using human evaluation. Fluency. Evaluate the fluency and naturalness of the generated text. This is particularly important for tasks like creative writing or dialogue generation. Coherence. Assess the logical flow and coherence of the generated response, especially when the task involves generating longer pieces of text or complex reasoning. Visualization. Plots. None. Fine-tune parameters. None. Uncertainty methods. None. Challenges and fixes. Challenge 1. API key management. Keeping your API key secure is crucial. Exposing it in your code can lead to unauthorized access and potential abuse. Sample use case. Including the API key directly in your code or storing it in a publicly accessible location. Fixes. Use environment variables to store your API key outside of your code. Consider using a secret management tool to securely store and access your API key. Challenge 2. Model selection. Choosing the right AI21 model for your specific task can be crucial for achieving optimal results. Sample use case. Using a model designed for creative writing for a summarization task, leading to suboptimal output. Fixes. Carefully read the documentation for each AI21 model to understand its strengths and limitations. Experiment with different models and compare their outputs to determine the best fit for your use case. Challenge 3. Prompt engineering. Crafting effective prompts is essential for guiding the AI21 model to generate the desired output. Ambiguous or poorly structured prompts can lead to unexpected or incorrect results. Sample use case. A prompt that is too general or lacks context, resulting in a response that is irrelevant or off-topic. Fixes. Provide clear instructions and context in your prompt. Use specific examples or templates to guide the model's understanding. Iterate on your prompts and test different variations to improve the quality of the outputs. Challenge 4. Handling long inputs. Some AI21 models have limitations on the length of input they can process. This can pose a challenge when working with lengthy documents or texts. Sample use case: trying to summarize a large document exceeding the model's input length limit. Fixes: break down the input into smaller chunks that fit within the model's limits. Consider using techniques like chunking or summarization at the document level before feeding the input to the AI21 model. Challenge 5: output interpretation: understanding the format and structure of the AI21 models. Output is essential for using it effectively in your application. Sample use case: difficulty extracting specific information or manipulating the output based on its structure. Fixes: carefully review the model's documentation to understand the expected output format. Use appropriate parsing or data extraction techniques to process the output according to your needs. Langchain AI21 chat models. Chat AI21. Description: the Chat AI21 model from AI21 Labs is a powerful language model designed for conversational applications. It excels at generating human-like responses, understanding context, and maintaining coherent dialogue. It's particularly useful for building chatbots, interactive stories, and dialogue-based applications. Inputs: text: the input text provided to the model for conversation. This can be a user message, a prompt, or a continuation of the conversation. Outputs: text: the model generates a text response based on the provided input and the conversation history. Steps: tokenization: the input text is broken down into individual tokens, which are the basic units of meaning in the model. Embedding: each token is mapped to a numerical representation embedding that captures its semantic meaning. Contextualization: the model processes the sequence of embeddings, considering the context of previous interactions in the conversation. Generation: the model predicts the probability of different tokens to follow the current context, and generates the most likely response. Metrics: perplexity measures how well the model predicts the next token in a sequence. Lower perplexity indicates better performance. Blue score evaluates the fluency and similarity of the generated text to human written references. Visualization plots: attention visualization: visualizing the attention weights during the model's processing can reveal how the model focuses on different parts of the input. Fine-tune parameters: learning rate controls how quickly the model adjusts its parameters during training. Batch size: number of examples processed at each step of training. Epochs: number of times the entire dataset is used for training. Uncertainty methods: temperature scaling adjusts the probability distribution of tokens to increase or decrease the model's confidence in its predictions. Challenges and fixes: challenge 1: generating responses that lack coherence or drift away from the original topic. Sample use case: a user asks a question about a specific topic, but the model starts generating irrelevant information. Fixes: use a more specific prompt to guide the model towards the desired topic. Employ techniques like memory to maintain context and prevent topic drift. Challenge 2: generating repetitive or generic responses. Sample use case: the model provides similar responses to different questions, lacking diversity and engagement. Fixes: fine-tune the model on a dataset specifically tailored to the desired conversational style. Implement techniques like diversity promotion to encourage the model to generate more unique and engaging responses. Langchain AI21 Contextual Answers. Description: this tool allows you to utilize the AI21 Studio's Contextual Answers API to generate informative answers based on provided context. The tool is built on Langchain, a framework for building and deploying language models. Inputs: Text: the text that serves as context for the answer generation. This could be a document, article, or any other text-based input. Question: the specific question you want to be answered based on the provided context. Outputs: answer: the generated answer, derived from the context and the question. Steps: the tool first takes the provided context and question as input. The context is then processed by the AI21 Studio's Contextual Answers API. This API utilizes a powerful language model to understand the context and identify relevant information. The API then uses this understanding to generate an answer that directly addresses the question, while staying within the bounds of the provided context. Metrics: accuracy: this measures how closely the generated answer aligns with the correct answer based on the provided context. Coherence: this assesses how well the answer flows logically and makes sense in the context of the question and provided text. Relevance: this evaluates how closely the answer relates to the original question and the context. Visualization plots: word cloud: this could visualize the most frequent words in the answer, highlighting important concepts. Attention map: this might show which parts of the context the model focused on when generating the answer, providing insights into its reasoning process. Fine-tune parameters: temperature controls the randomness of the generated answer. Higher temperature leads to more creative and diverse answers, while lower temperature produces more predictable and focused answers. Top K limits the number of possible words considered at each step of answer generation. Smaller values increase speed but may limit the diversity of answers. Top controls the probability distribution of words considered at each step. Lower values favor more common and predictable words, while higher values allow for more diverse and unexpected words. Uncertainty methods: confidence score: this provides a numerical measure of the model's confidence in the generated answer. Higher scores indicate more certainty. Multiple answers: the tool could generate multiple possible answers with different confidence scores, allowing users to choose the most suitable one. Challenges and fixes: Challenge 1: the generated answer may be overly short or incomplete. Sample use case: when the question is complex and requires a detailed explanation, the answer might only provide a brief summary. Fixes to challenge 1: increase the max tokens parameter to allow for longer responses. Use a larger language model for better context understanding and more comprehensive answers. Challenge 2: the generated answer may contain factual errors or inconsistencies with the provided context. Sample use case: the model might misinterpret the context or misremember information, leading to incorrect or misleading answers. Fixes to challenge 2: ensure that the provided context is accurate and comprehensive. Use a model that is specifically trained for factual accuracy, such as a factual language model. Challenge 3: the generated answer may not be creative or engaging enough. Sample use case: when the question requires a creative or imaginative response, the answer may be too literal or predictable. Fixes to challenge 3: increase the temperature parameter to encourage more diverse and creative answers. Use a language model known for its creative capabilities. Challenge 4: the generated answer may not be relevant to the question or context. Sample use case: the model might focus on irrelevant information or misunderstand the intended meaning of the question. Fixes to challenge 4: clarify the question and ensure it is clearly phrased. Use a language model with strong context understanding capabilities. Challenge 5: the API call might fail due to errors such as rate limiting or invalid inputs. Sample use case: the provided context or question might be too long or contain invalid characters. Fixes to challenge 5: Ensure the inputs are within the acceptable limits and format. Handle errors gracefully, providing informative messages to the user. Implement rate limiting logic to avoid exceeding API usage limits. YAML. Langchain AI21 Contextual Answers AI21 Contextual Answers. Description: this tool utilizes the AI21 Studio's Contextual Answers API to extract relevant answers from a provided text based on a given question. This is a powerful tool for question answering, knowledge extraction, and summarization tasks. Inputs. Question: the question for which an answer is being sought. It should be a natural language question related to the context provided. Text: the text from which the answer will be extracted. This can be a document, article, or any other textual content. Outputs. Answer: the extracted answer from the provided text, relevant to the input question. Confidence: a score indicating the AI21 model's confidence in the provided answer. Steps. The input question and text are sent to the AI21 Contextual Answers API. The AI21 model processes the text and identifies the most relevant passages based on the input question. The model then extracts the answer from the relevant passages and returns it, along with a confidence score. Metrics. Accuracy: the percentage of questions for which the extracted answer is correct and relevant to the input question. Confidence score: the model's confidence in the provided answer, ranging from 0 to 1. Visualization plots. None. Fine-tune parameters. None. Uncertainty methods. Confidence score: this provides a measure of the model's certainty about the extracted answer. Challenges and fixes. Challenge 1: ambiguity in the question. When the question is vague or can have multiple interpretations, the model might return an answer that is not entirely relevant. Sample use case that resulted in challenge 1: what is the capital of France? The user might be asking for the current capital or a historical capital. Fixes to challenge 1: provide more context or a specific time frame in the question to remove ambiguity. Challenge 2: long text. When the input text is very long, the model might struggle to extract the most relevant information, potentially leading to inaccurate or incomplete answers. Sample use case that resulted in challenge 2: providing an entire book as input text. Fixes to challenge 2: split the text into smaller, more manageable chunks, or use tools like document summarization to extract relevant information before feeding it to the model. Challenge 3: unclear relation. When the question is not directly related to the provided text, the model might return an answer that is irrelevant or based on a misunderstanding. Sample use case that resulted in challenge 3: asking about the causes of the American Civil War, while providing a text about World War II. Fixes to challenge 3: ensure the provided text is relevant to the question being asked. If not, provide a different text or refine the question. Langchain AI21 Contextual Answers. Contextual answer input. Description: the contextual answer input class defines the input structure for the AI21 Contextual Answer tool in Langchain. This tool leverages the AI21 Studio's contextual answer functionality to extract relevant information from a given context and answer a specific question. Inputs. Question: the question to be answered based on the provided context. Context: the textual context from which the answer should be derived. Outputs. Answer: the extracted answer to the question based on the context. Steps. The contextual answer input is initialized with the question and context parameters. The AI21 Contextual Answer tool takes the contextual answer input as input. The tool then utilizes AI21 Studio's contextual answer functionality to process the context and question. Finally, the tool returns the extracted answer as the output. Metrics. Accuracy evaluates the correctness of the extracted answer against a known ground truth. Coherence measures the clarity and logical flow of the answer. Relevance assesses the degree to which the answer is related to the provided question and context. Visualization plots. Attention visualization visualizes the attention weights assigned to different parts of a context during the answer extraction process. Fine-tune parameters. Temperature controls the randomness of the answer generation process. Higher values lead to more creative and diverse answers, while lower values favor more deterministic and predictable responses. Uncertainty methods. Confidence score. AI21 Studio provides a confidence score indicating the model's certainty about the extracted answer. Challenges and fixes. Challenge 1. The context may be too short or incomplete to provide a comprehensive answer to the question. Sample use case that resulted in Challenge 1: asking a complex question about a historical event, using a single sentence description of the event. Fixes to Challenge 1. Provide a more detailed and informative context. Use a different tool or method for answering the question if a suitable context is unavailable. Challenge 2. The context might contain irrelevant or contradictory information, leading to inaccurate or misleading answers. Sample use case that resulted in Challenge 2: asking about the population of a city using a document that also discusses its history and economy. Fixes to Challenge 2. Pre-process the context to remove irrelevant information. Use a technique like question answering with context filtering to focus on relevant parts of a context. Challenge 3. The AI21 Studio API might encounter errors or timeouts, leading to failures in answer extraction. Sample use case that resulted in Challenge 3: a network issue or API server overload prevents the tool from accessing AI21 Studio's services. Fixes to Challenge 3. Check for internet connectivity and ensure the API server is reachable. Retry the request after a brief delay. Use a different tool or method if the issue persists. Challenge 4. The question might be ambiguous or too broad, leading to multiple possible answers. Sample use case that resulted in Challenge 4: asking what is the history of the company, without specifying a specific company. Fixes to Challenge 4. Reformulate the question to make it more specific and precise. Provide additional context or constraints to guide the answer extraction process. Langchain AI21 embeddings. Description. Explain in detail. The Langchain AI21 embeddings are a specialized embedding model offered by AI21 Labs, tailored for natural language processing tasks. It leverages AI21's advanced language understanding capabilities to represent text as numerical vectors, capturing semantic relationships and contextual information within the text. These embeddings are designed to be effective for tasks like text similarity search, clustering, and classification, particularly when working with complex and nuanced linguistic data. Inputs. Input 1. Explain in detail text input. The Langchain AI21 embedding model accepts text as input, which can be a single sentence, a paragraph, or even a complete document. Input 2. Explain in detail language. The model operates on text data and requires the specification of the language of the input text. Outputs. Output 1. Explain in detail numerical vector. The output of the Langchain AI21 embedding model is a high-dimensional vector representing the semantic content of the input text. This vector encapsulates the meaning and relationships within the text. allowing for comparisons and analysis with other text embeddings. Output to explain in detail similarity score optional when comparing two text embeddings. The model can optionally provide a similarity score indicating how closely related the two texts are based on their semantic content. Steps. Step 1. Explain in detail text preprocessing. The input text is preprocessed to prepare it for embedding. This might involve normalization, tokenization, and handling of special characters or punctuation. Step 2. Explain in detail embedding generation. The preprocessed text is then fed into the Langchain AI21 embedding model, which generates a numerical vector representing the semantic content of the text. Metrics. Metric 1. Explain in detail cosine similarity. This metric measures the cosine of the angle between two vectors, providing a value between 0 and 1, where 1 indicates perfect similarity and 0 indicates no similarity. Metric 2. Explain in detail Euclidean distance. This metric calculates the straight line distance between two vectors, where smaller distances indicate higher similarity. Visualization plots. Visualization plot 1. Explain in detail scatter plots. These plots visualize the relationships between different text embeddings in a multi-dimensional space, allowing for visual exploration of similarities and clusters. Visualization plot 2. Explain in detail T-SNE plots. This technique can be used to reduce the dimensionality of text embeddings while preserving their relationships, making it easier to visualize patterns and clusters in lower dimensional spaces. Fine-tune parameters. Parameter 1. Explain in detail embedding dimension. This parameter controls the size of the numerical vector produced by the model. A higher dimension generally provides more nuanced representation but may require more computational resources. Parameter 2. Explain in detail model variant. AI the 21st of May offer different variants of the Langchain AI21 embedding model, each optimized for specific use cases or languages. Selecting the appropriate variant can improve performance for particular tasks. Uncertainty methods. Uncertainty method 1. Explain in detail confidence scores. The model may provide confidence scores for its embeddings, indicating how certain it is about the generated representation. This can help identify potential areas of uncertainty or ambiguity in the text. Uncertainty method 2. Explain in detail ensemble methods. Combining multiple embedding models can reduce uncertainty and improve robustness by leveraging the strengths of different models. Challenges and fixes. Challenge 1. Explain in detail computational cost. Generating embeddings for large amounts of text can be computationally demanding. Sample use case that resulted in Challenge 1. A large-scale text retrieval system requiring embeddings for millions of documents. Fixes to Challenge 1. Optimize embedding generation parameters. Consider using efficient hardware, and explore techniques like batch processing or parallel computation to distribute the workload. Challenge 2. Explain in detail overfitting. The embedding model may overfit to the training data, leading to poor performance on unseen data. Sample use case that resulted in Challenge 2. A sentiment analysis task trained on a dataset with specific sentiment expressions that are not representative of real-world usage. Fixes to Challenge 2. Use larger and more diverse training datasets. Implement regularization techniques to prevent overfitting, and monitor performance on a validation set during training. Langchain AI21 embeddings. AI21 embeddings. Description. Explain in detail. The AI21 embeddings class provides a way to generate embeddings using the AI21 Studio API. It leverages the AI21 Studio's powerful language model to convert text into numerical Representations embeddings. These embeddings capture semantic relationships between words and phrases, making them useful for tasks like similarity search, text clustering, and recommendation systems. Inputs. Input 1. Explain in detail text. This input represents the text that you want to convert into an embedding. It can be a single string or a list of strings. Outputs. Output 1. Explain in detail embedding. This output represents the numerical embedding generated by the AI21 Studio API. It is a list of floating point numbers, where each number corresponds to a dimension in the embedding space. Steps. Step 1. Explain in detail. The AI21 embeddings class first takes the input text and sends it to the AI21 Studio API. Step 2. Explain in detail. The AI21 Studio API processes the text and returns a numerical representation embedding of the text. This embedding is a list of floating point numbers. Metrics. Metric 1. Explain in detail cosine similarity. Cosine similarity is a common metric used to measure the similarity between two embeddings. It ranges from -1 to 1. With 1 indicating perfect similarity and -1 indicating perfect dissimilarity. Metric 2. Explain in detail Euclidean distance. Euclidean distance measures the straight line distance between 2 points in the embedding space. Lower distances indicate higher similarity. Visualization plots. Visualization plot 1. Explain in detail T-SNE. T-distributed stochastic neighbor embedding. T-SNE is a dimensionality reduction technique that can be used to visualize high-dimensional embeddings in a lower dimensional space, often 2D. It helps to understand the relationships between different text items based on their embeddings. Visualization plot 2. Explain in detail UMAP. Uniform manifold approximation and projection. UMAP is another dimensionality reduction technique that can be used to visualize embeddings. It often produces more intuitive and interpretable visualizations compared to T-SNE. Fine-tune parameters. Parameter 1. Explain in detail model name. This parameter allows you to specify the AI21 Studio model to use for embedding generation. Different models may produce embeddings with varying levels of performance and semantic understanding. Parameter 2. Explain in detail API key. This parameter is essential for authenticating with the AI21 Studio API. You need to obtain an API key from AI21 Studio to use this class. Uncertainty methods. Uncertainty method 1. Explain in detail ensemble embeddings. One approach to address uncertainty is to create an ensemble of multiple embeddings from different models or different versions of the same model. Averaging these embeddings can reduce variance and improve robustness. Uncertainty method 2. Explain in detail confidence scores. Some embedding models might provide confidence scores along with the embeddings. These scores can indicate the model's confidence in the generated embeddings, allowing for better handling of uncertain cases. Challenges and fixes. Challenge 1. Explain in detail API key management. Ensuring secure storage and rotation of your API key is crucial to prevent unauthorized access to your AI21 Studio account. Sample use case that resulted in Challenge 1 in a production environment. Hardcoding the API key directly into the code can pose a security risk if the code is compromised. Fixes to Challenge 1. Store API keys securely in environment variables or use a dedicated secret management system. Rotate API keys regularly to minimize the impact of potential breaches. Challenge 2. Explain in detail model selection. Choosing the right AI21 Studio model for your embedding task can be important for achieving the desired level of performance. Sample use case that resulted in Challenge 2. Using a model that is not well suited for your specific domain or task can lead to suboptimal embeddings. Fixes to challenge to experiment with different AI21 Studio models and evaluate their performance on a representative dataset to identify the best model for your needs. Consider using AI21 Studio's model documentation to understand the strengths and limitations of each model. Langchain AI21 LLMs. Description: explain in detail. The Langchain AI21 LLM integration allows you to use AI21 Studio's powerful language models within your Langchain applications. This provides access to a range of models like Jurassic 1 Jumbo, Jurassic 1 Jumbo for code, Jurassic 1 Jumbo for dialogue, and Jurassic 1 Jumbo for writing. These models offer advanced capabilities in text generation, translation, summarization, question answering, and more. Inputs. Input 1. Explain in detail text input. This is the text you want to feed into the model, such as a prompt for text generation or a passage for summarization. Input 2. Explain in detail parameters. You can provide additional parameters to fine-tune the model's behavior. For instance, you can specify the model's temperature, top, and maximum length. Outputs. Output 1. Explain in detail text output. The generated response from the AI21 model, based on your input and parameters. Output 2. Explain in detail metadata depending on the specific model and task. You might receive additional metadata alongside the text output, such as probabilities or other relevant information. Steps. Step 1. Explain in detail. Initialize the AI21 LLM instance. Use the AI21 Studio class from Langchain to instantiate the model you want to use, specifying your API key and the model name. Step 2. Explain in detail. Call the model. Use the run method of the LLM instance to execute the task with your input text and any parameters. Metrics. Metric 1. Explain in detail accuracy. Evaluate the model's ability to generate accurate and relevant responses based on the task. Metric 2. Explain in detail coherence and fluency. Assess the quality and flow of the generated text, ensuring it is grammatically correct and readable. Visualization plots. Visualization plot 1. Explain in detail now. Visualization plot 2. Explain in detail now. Fine-tune parameters. Parameter 1. Explain in detail temperature. Controls the randomness of the generated text. Higher values lead to more creative and unpredictable outputs. Parameter 2. Explain in detail top K. Limits the number of possible words considered at each step during generation, reducing the probability of unexpected or irrelevant words. Uncertainty methods. Uncertainty method 1. Explain in detail now. Uncertainty method 2. Explain in detail now. Challenges and fixes. Challenge 1. Explain in detail API key issues. If your AI21 API key is incorrect or invalid, you'll encounter errors when trying to connect to the service. Sample use case that resulted in challenge 1 when running a Langchain application using the AI21 LLM. You might receive a 401 unauthorized error message. Fixes to challenge 1. Ensure you've entered the correct AI21 API key within your Langchain code. Verify that the API key has been properly generated and is associated with the correct AI21 Studio account. Challenge 2. Explain in detail rate limiting. Excessive requests to the AI21 API can lead to rate limiting, preventing your application from functioning properly. Sample use case that resulted in challenge 2. You might experience delays or errors in your application, indicating that you are exceeding the API's usage limits. Fixes to challenge 2. Implement a mechanism to control the frequency of requests to the API, perhaps by introducing delays or using a queuing system. Monitor the API usage and adjust your code accordingly to prevent exceeding the rate limits. Langchain AI21 LLMs AI21 LLM. Description: explain in detail. The AI21 LLM class in Langchain provides an interface for interacting with AI21 Studio's powerful large language models (LLMs) directly within your Python applications. This class leverages AI21 Studio's API to seamlessly access and utilize AI21's state-of-the-art language models, such as Jurassic 1 Jumbo and Jurassic 1 Jumbo. Inputs. Input 1: explain in detail the text or prompt that you want to send to the AI21 LLM. This can be a string containing your question, request, or any text you want the model to process. Input 2: explain in detail optional parameters for the AI21 LLM, such as temperature, top, and more. These parameters can be used to fine-tune the model's behavior and adjust the level of creativity or randomness in its responses. Outputs. Output 1: explain in detail the text generated by the AI21 LLM as a response to your input prompt. This output will typically be a string containing the model's response, which can range from simple sentences to more complex and creative text formats. Output 2: explain in detail metadata associated with the model's response, such as information about the model used, the processing time, or any error messages that may have occurred. Steps. Step 1: explain in detail. The AI21 LLM class initiates a connection to AI21 Studio's API using your API key, which you must provide when initializing the class. Step 2: explain in detail. Your prompt is sent to the selected AI21 LLM through the API connection, and the model processes the prompt according to its training and parameters. Metrics. Metric 1: explain in detail the latency or processing time required for the AI21 LLM to generate a response to your prompt. This metric helps assess the speed and efficiency of the model's processing. Metric 2: explain in detail the quality or accuracy of the model's response can be evaluated through various metrics, such as perplexity, BLEU score, or human evaluation. Visualization plots. Visualization plot 1: explain in detail depending on the specific use case. You could visualize the response's structure, the probability distribution of tokens generated, or the model's attention patterns. Visualization plot 2: explain in detail. Visualizing the model's performance over time can help identify trends, improvements, or potential biases in its responses. Fine-tune parameters. Parameter 1: explain in detail temperature. This parameter controls the randomness of the models output. Higher temperatures result in more diverse and creative responses, while lower temperatures produce more predictable and consistent outputs. Parameter 2: explain in detail top K and top. These parameters limit the possible output tokens based on their probabilities. Top K selects the top K most probable tokens, while top considers all tokens until their accumulated probability reaches a threshold of P. Uncertainty methods. Uncertainty method 1: explain in detail. The AI21 LLM class doesn't explicitly provide uncertainty estimation methods within its interface. However, you can utilize external techniques like Bayesian inference or dropout to estimate uncertainty in the model's predictions. Uncertainty method 2: explain in detail. You could incorporate methods like Monte Carlo dropout or ensemble models to quantify the uncertainty associated with the AI21 LLM's responses. Challenges and fixes. Challenge 1: explain in detail. Rate limiting. AI21 Studio may impose rate limits on API requests to prevent abuse or excessive usage. Sample use case that resulted in challenge 1 submitting a large number of requests in a short period may trigger rate limiting, causing delays or errors. Fixes to challenge 1 implement a strategy to respect rate limits, such as introducing delays between requests or using asynchronous requests to distribute the load. Challenge 2 explain in detail model availability. The specific AI21 model you wish to use might not always be readily available due to maintenance or resource constraints. Sample use case that resulted in challenge 2 trying to access a model that is temporarily unavailable can lead to errors or unexpected behavior. Fixes to challenge 2 implement error handling mechanisms to gracefully manage situations where the desired model is unavailable. You might consider using a fallback model or retrying the request after a delay. Langchain AI21 Semantic Text Splitter. Description explain in detail. The Langchain AI21 Semantic Text Splitter is a text splitter specifically designed for splitting text into chunks that are semantically coherent, meaning they preserve the meaning and flow of the original text. It leverages the AI21 Labs API, a powerful language model. To achieve this, inputs text the input text that needs to be split into chunks. This can be any text format, like plain text, articles, documents, etc. Chunk size the desired size of each chunk in tokens words. This defines the granularity of the splitting process. Outputs. Chunks a list of strings representing the individual text chunks generated by the splitter. Each chunk maintains semantic coherence within its boundaries. Steps. The text is first tokenized. This breaks the text down into individual units, often words, which the AI21 Labs API can process. The API then analyzes the text, identifying semantic boundaries points where the meaning shifts within the input text. Using these boundaries, the splitter divides the text into chunks that preserve the semantic flow and minimize disruptive cuts. Metrics. Coherence score measures how well the meaning and flow of the original text is preserved within each chunk. Chunk size distribution shows how the sizes of the generated chunks vary. Visualization plots. Semantic boundary visualization. A plot highlighting the locations of the semantic boundaries identified by the AI21 Labs API. Chunk size distribution histogram. A visualization depicting the distribution of chunk sizes across the split text. Fine-tune parameters. Chunk overlap controls the amount of overlap between chunks, allowing for smoother transitions between chunks. Chunk size defines the size of each chunk in tokens words. Uncertainty methods. The AI21 Labs API uses internal uncertainty estimation techniques to determine semantic boundaries, but this is generally not exposed as a separate uncertainty metric. Challenges and fixes. Challenge 1 handling text with complex semantic structure. Sample use case that resulted in challenge 1 text with intricate relationships between ideas, such as philosophical essays or technical manuals, can be challenging to split effectively. Fixes to challenge 1. Experiment with different chunk size values. Smaller chunks can sometimes better capture the finer nuances of complex text. Utilize chunk overlap to mitigate disruptions in meaning between chunks when dealing with intricately connected ideas. Challenge 2 splitting text with multiple languages. Sample use case that resulted in challenge 2 text containing multiple languages, e.g. a multilingual document or a code snippet mixed with natural language can pose problems for semantic splitting. Fixes to challenge 2. For multilingual text, consider pre-processing the text to segment it based on language before using the semantic splitter. Explore using language-specific versions of the AI21 Labs API. if available. For more accurate results, Langchain AI21 Semantic Text Splitter AI21 Semantic Text Splitter. Description: the AI21 Semantic Text Splitter is a text splitter designed to break down large pieces of text into smaller chunks, preserving semantic coherence. It uses AI21's advanced language understanding capabilities to identify natural breakpoints in a text based on its meaning, rather than just character counts or sentence boundaries. This approach helps ensure that the resulting chunks are meaningful units of information, making them suitable for downstream tasks like question answering or summarization. Inputs: text: the input text that needs to be split. This can be a long document, article, or any other text-based content. Chunk size: the desired size of each chunk. In tokens, this parameter helps control the granularity of the splitting process. Chunk overlap: the number of tokens that should overlap between consecutive chunks. This helps maintain context across chunks and prevent information loss at the boundaries. Outputs: list of chunks: a list of text chunks, each representing a semantically coherent portion of the input text. These chunks are ready to be processed by other language models or tools. Steps: text preprocessing: the input text is initially preprocessed to remove any irrelevant information or formatting that might interfere with the semantic segmentation. This could involve tasks like removing punctuation, white space, or special characters. Semantic segmentation: the core of the AI21 Semantic Text Splitter lies in its ability to identify natural breakpoints within the text based on semantic meaning. This involves leveraging AI21's language understanding capabilities to understand the relationships between words and phrases, and to determine where logical boundaries occur within the text. Chunk creation: once the text is segmented, the splitter divides it into chunks of the specified size, ensuring that each chunk represents a meaningful unit of information. The overlap parameter ensures that some context is preserved at the boundaries of chunks. Metrics: semantic coherence: the quality of the semantic segmentation is crucial, as it directly impacts the coherence of the generated chunks. Metrics like perplexity or coherence scores can be used to assess how well the splitter preserves semantic meaning within chunks. Chunk size consistency: it's important to ensure that the generated chunks are relatively consistent in size, especially for downstream tasks that require uniform input. Metrics like standard deviation of chunk sizes can help assess this consistency. Visualization plots: chunk size distribution: a histogram showing the distribution of chunk sizes can provide insights into the splitter's performance and the consistency of the generated chunks. Semantic segmentation visualization: visualizing the identified breakpoints within the input text can help understand how the splitter segments the text based on meaning. Fine-tune parameters: chunk size adjusting: this parameter can control the granularity of the splitting process. Smaller chunk sizes will result in more chunks, while larger sizes will create fewer but potentially larger chunks. Chunk overlap: this parameter allows for adjusting the amount of overlap between chunks. Increasing the overlap helps maintain context across chunks, but can also lead to redundancy. Uncertainty methods: confidence scores: the AI21 Semantic Text Splitter can potentially provide confidence scores for each identified breakpoint. These scores can be used to assess the certainty of the splitter's decisions, allowing for adjustments based on the confidence level. Alternative breakpoints: the splitter could also provide alternative breakpoints along with their confidence scores to allow for exploration of different segmentation options. Challenges and fixes: Challenge 1. Handling complex sentences with multiple clauses or long noun phrases. Sample use case that resulted in Challenge 1. Splitting a sentence like the company, which was founded in 2000, announced its plans to expand into new markets. Despite facing some challenges in its current operations, this sentence contains multiple clauses and long phrases, making it difficult for the splitter to accurately identify semantic boundaries. Fixes to Challenge 1. Incorporate advanced sentence parsing techniques to better understand the structure and meaning of complex sentences. Utilize contextualized word embeddings to better capture the relationships between words within a sentence and identify the semantic boundaries. Challenge 2. Dealing with highly technical or specialized text where domain-specific knowledge is crucial. Sample use case that resulted in Challenge 2. Splitting a text on advanced medical topics, where the splitter might struggle to understand the nuances of medical terminology and concepts. Fixes to Challenge 2. Integrate domain-specific knowledge into the splitter's training data or through external knowledge sources. Use specialized language models that have been fine-tuned on specific domains like medicine or finance. Challenge 3. Maintaining semantic coherence when handling texts with multiple languages or different writing styles. Sample use case that resulted in Challenge 3. Splitting a document containing both English and Spanish text, where the splitter might struggle to preserve meaning across language boundaries. Fixes to Challenge 3. Employ multilingual language models capable of understanding and processing text in multiple languages. Implement language detection mechanisms to identify the language of each chunk and apply appropriate splitting strategies. Challenge 4. Handling texts with inconsistent formatting, such as bullet points or lists. Sample use case that resulted in Challenge 4. Splitting a document containing a bulleted list of items, where the splitter might struggle to maintain semantic coherence due to the lack of clear sentence boundaries. Fixes to Challenge 4. Implement logic to recognize and handle different formatting elements within the input text. Leverage information about list structure and indentation to identify semantic boundaries.